Right. Here we go. Sorry about the late start. A couple minutes late, but we'll just go a little bit extra today. Anyways, welcome back. It's been a week. Welcome back to the Fridays open studio design session. If you're new around here, this is really meant to be kind of a working session. Given this current state of the world with quarantine and whatnot, I thought it'd be a good idea to do these so that you can work on your own projects while I work on mine, and there's kind of like a atmosphere of creativity here. So I encourage you guys to work on your own projects and just have this on in the background if you're not watching it, because I know like watching it would or listening in would be very boring. So I encourage you guys to actually just do your own projects while having this on in the background. So with that said, most of you who are watching this are returning probably. Right, you guys are subscribed, so that's that. I'm really at a loss for words today. I don't feel super talkative for some reason, but we'll just do our best here to just carry the show on. So last time, kind of the logistics of things. Last time we finished off covering the underside here, and also that might have been actually two different sessions for covering this underside and also the nose modeling here. But point is, we got to a point where we kind of said, okay, this looks a little bit too weird, right? This really should be tapered like that. So we're probably gonna have to end up cutting away some of the structure here, modifying this a little bit before working on the intake structure, which is going to be hanging off here. And that's going to be, I think we said last time, it's going to be done via the same process that we used for the canopy here. Right, this canopy was lofted using several cross sections and a center spline, or I guess I don't know what you call it, like a keel or something. Basically, it's two perpendicular parts that kind of have a half cut, right? And then they fit together and form a very strong joint. And it's a very defined geometry, right? You can't really achieve this with normal surface modeling methods, but it's possible if you just spend the time and do it. And from the canopy, it looks pretty decent, actually. It might be a little bit overexposed in this live stream, but it's I think it's a pretty nice shape. It just takes a lot of time to calibrate and make it work. So I think of this as like kind of a sculpture of sorts, but this sculpture actually flies in the end. So take it for what it is. So I guess we're gonna do the same thing on the bottom. We're gonna use the same technique that we used here for the canopy of creating cross sections and creating a loft, and we're going to model the intake that's that starts at this mark right here that I put down, and it's gonna go back and taper off. So the interesting thing about this design is that it's not actually a constant thickness I guess underside inlet structure engine thing. Sorry about that mess of words there, but it's it's thinner at the forward end, and it kind of increases in thickness, in depth, and then it's constant for a little bit before tapering back down. And then so that's what we're gonna try and achieve in today's session. I don't know how far we're gonna get. We'll probably be able to create like a center structure here, and then several of the cross sections, but I'm not sure about completing the lofting structure here because it does take a lot of time to do that properly. But after that, I mean, this thing is pretty much done. It's looking great right now, in my opinion. So, let's just jump right in, I guess. And again, if you're watching this stream, I encourage you guys to work on your own projects in the same at the same time. I'll try not to talk too much. Um, Hopefully, it creates kind of a studio environment. So yeah, let's get started. So I guess the first step here, just move this out of the way. I think I saw a comment here in the chat. That looks really good. Hey, thanks, man. Benjamin Rogers. He's a longtime supporter, follower, I guess. um, yeah, thanks. It just takes a lot of time, right? That's the only trade-off. The materials themselves, it's pretty cheap, right? Cardstock is really cheap. Paper clips are cheap. Popsicle sticks are cheap. Tape is cheap. So everything you need to build this is pretty cheap. But to get it into a final form that looks great, I think you got to spend the time, and that's where I guess the costs of a certain plane go up. Is manufacturing time. But I guess let's just get started here with the bottom. Just grab a couple of tools. Sorry about the late start again. Worked a little bit late today, so get scissors, eraser, pencil, X-Acto knife. Right. So these are the tools that I use, right? And I guess really to get started, we need to remove some of this material here, because I think we said last time it's a little bit too thick, and we need the spline to be able to come up all the way here. So this is actually blocking the way a little bit. I'm a little hesitant again because I don't want to disassemble it or cut it too much beyond repair, but we do need to reduce some of the thickness here because the intake starts here, right? And it's a little weird having such a big bulge here. It needs to taper down really, and you can't really do that, I guess. I mean, I tried taping it, but obviously it's still bulging out a little bit, so we need to cut this straw structure here, and maybe do some cuts to the actual cardstock itself. But we can start with removing this part here. I'm not going to use this X-Acto knife to cut quite yet. Just going to slide this underneath and try and pry open so this is dangerous. You should probably not cut towards yourself, but just be careful, I guess. Yeah, I'm just doing that to repair this. Shoot, stuck down. It's all right, there we go. So this is gonna be a little bit of surgery, I guess you could call that. I don't know how else to describe this other than surgery. So I actually tape this quite snugly, so I take a little bit of finessing to actually get it to work. I want a clean cut, so I'm going to try and remove as much material as I can before... oh shoot, yeah, it's ripping off a little bit of the cardstock there. But no matter, we're probably going to remove some of that cardstock anyway. So just going to rip this off a little bit. Alright, yeah, this is really secure. So you can tell the adhesive, it actually is really strong. It's just sometimes you gotta, tape it right to get a very secure joint. Okay, so this is looking all right. I think for this piece right here, we might need to cut it. Actually, if we cut it here and tape this, this edge right here flat against the underside, we might actually achieve that shape a little better than what we had previously. So I'm not sure an X-Acto knife is the best option here. So I'm gonna try and use scissors real quick. Okay, yeah, scissors are not gonna work. It's your scissors, you have two blades here and you're trying to cut on the center line. So ideally you would have a little gap here, right, so that you can cut right on the line. But since we're not able to do that, I feel like an X-Acto knife would be the best option here. So I'm just going to just slowly but surely work my way through this. You can almost like kind of, I don't know, like prime this to be cut later by a scissor. I don't know how that works, but okay, actually let's just do this. I actually have no idea what I'm doing. I'm just working with the material, seeing what works, what doesn't work, just kind of tinkering. So I'm gonna fold it over this cardstock edge, and then I'm gonna just slice it open like this. I'm gonna put the blade underneath, and so this is a little bit dangerous. It's not moving too much, so there's a lot of energy in this because I'm trying to exert a force and it's not cutting. So you want to be careful when you do this. You don't want to injure yourself making a plane. That would be tragic. Safety first, Though you really should be wearing safety glasses, but since we're not, doing heavy duty cuts or anything like that, I feel like that's a little bit overkill. I'm just kind of stream of consciousness spitting out words today. I'm sorry about that. No definite plan in sight. Okay, let's actually try assembling this and seeing if it reduces the thickness up here a little bit, because remember it was going all the way back here, which was unnecessary, and it's gonna block the loft structure. So now we are, sorry, I'm just blowing the dust off this tape here. Now we're cutting this structure off and then just trying to flatten out this little piece here. So this is, again, this is not like a precise thing. It's not like precision engineered parts fitting together. It's literally just tape as you go, kind of I think of it like sculpture, right? It's somewhere in between art and engineering, proper engineering. So this is kind of where I like to operate. So yeah, just clean up some of this tape edge. And this might be boring, so I encourage you guys to work on your own projects. So you don't have to watch this. But if you are interested in seeing how I actually make this, then, well, these streams record everything, hopefully. And if the stream gets corrupted, I'll just start another one and go up until the 2 hour 10-minute mark. But I can't really control that. That's out of my jurisdiction here. The YouTube app sometimes crashes during live streams and I am unable to continue. So let's just hope that doesn't happen today. But if it does, the recorded stream will be a little bit shorter, but I'll still go up until the 2 hour 10-minute mark. So again, let's just trim some of these excess pieces off. This is kind of how I like to work. I mean, there are different approaches to this. Like you can definitely, tape everything down and then cut the excess all off in the end. But I prefer to have like a clean workpiece so that, the scraps don't get in the way. They don't annoy me and piss me off, I kind of like cleaning things and making it, I guess, kind of ready to go for the next step as we go. So that's kind of why it takes a long time to um, make these planes. So anyways, it looks good. I think, the side profile looks a lot better, right? This taper, if you look at a real life, cross section, it kind of matches with the, I don't know how you can say match like that, but it kind of converges with the top kind of contour here, right? So this bottom edge here, it comes together with the top here, but it does so at this location behind the canopy, approximately, right? So that's why we needed to end this thickness a little bit earlier so we can actually do that taper so that it points at this location. So that's kind of my thinking behind this, right? I'm subscribed to like a lot of aviation pictures on Instagram, those kinds of accounts, and this is just an observation that I noticed from viewing a picture of an F-16 during like a takeoff or something. So fun fact. So I guess with that done, we can really get started with the underside here. We're really just trying to build the intake structure today. So I guess to do that, instead of hand wavy drawing a intake, I'm gonna get my iPad real quick and we're gonna trace out some shapes, and it's gonna be great. All right, I just need to open the app real quick. Let me set it up and we'll be on our way. So the app I use is called Trace Table. All right, so it's this app right here. So this app is, it's like $1, but I feel like it's worth it because it's, the application for it here for this particular hobby is like really, really good. I mean, you can definitely just use your typical Photos app, but it's it's a little bit finicky, right? Let me just pull up a picture of a F-16 real quick here. All right, so let me just close out of all the other apps so you don't see what I'm doing. I like my privacy, right? So here we go. This is an iPad Pro 12.9 inch 2018 model. It doesn't have the LiDAR or anything, but this is how I get my exact geometries, right? If you recall, this is kind of how I traced the initial shape and started to build the F-16 model that I have here. So in order to scale it, I am going to, okay, so as you can tell, it's a little bit finicky. So we'll have to use like a reference piece. This drawing is to scale to itself, right? So this canopy is the same width here as it is here in this section of the drawing. So what we're gonna do is, since everything is scaled properly in this picture, right, relative to each other, we can size a specific part to our actual F-16, right? And then after doing that, we can derive a contour line. So this is going to be a little bit abstract, right, unless you actually follow through with the process. But from a previous stream, this might be like 5 or 6 streams before this, we actually made the vertical stabilizer using this drawing, right? And this piece right here is pretty simple to match up against this I guess diagram. This diagram I just pulled off of Wikipedia. Like, you can just go on Wikipedia and search up F-16 and then download the schematic. It's like, it's not really a schematic, it's like an outer mold line, right, drawing. So OML drawing, people do these quite well. These are not the official designs, but they're very close, right? I imagine like the people who make these drawings actually take pictures of the planes, and then uh, trace out a shape and do some modeling to figure out like what it looks like from these angles. But because the manufacturer is definitely not going to release the plans for this thing, right? That's just it's a defense product, so you wouldn't post blueprints for that on the internet. So we're gonna grab the template that we made for the vertical stabilizer, and we're gonna match it to this, and then we're gonna lock the screen. So let me just do that real quick. Try to find the part. All right. Yeah, it's been a while. It's been a while since we made the template, but you can see all the pieces here that we're working with. I might need this gray cardstock piece, so I'm gonna actually take this out. So I also made a X47 in a past stream, so if you want to go watch that, you can. I'm still trying to make a video for it, but it's taken a while. I want to use my full frame camera to make the video, but there are some hurdles in the way in data transferring and things like that. All right, so as you can see, this is what we have for the template for the vertical stabilizer here. So there's this button up here in this app where you can lock touch control. So now when you touch it, it doesn't do anything, which is good because we need to trace this shape. So it's a little bit large, so I need to zoom out a little bit. Oh shoot, that might have been too much. Not sure. No, it's still a little big. You can go a little bit smaller. Yeah, this is quite finicky, if I do say so myself. So you just got to be patient with it. This technology is already helping you get the exact shape, so you just got to be patient and work with it to scale everything. Right, so this seems a little big still. Reduce the size a little bit, lock it in place. It's a little bit large. There's a little bit of a gap here. I don't know if you guys can see that, but yeah, there's a tiny gap. It's not a huge deal, but when you're trying to scale things, you want it to be as close as possible. Right, so just reduce the shape, or reduce the size a little bit more. Lock this in place. And then, yeah, that looks decent. All right, so we have kind of matched this in place, but I think what we did when we created this template was we drew on the black outline itself, so it's actually a little bit larger than expected here. So now I think we're getting really close. It just takes a little bit of adjustment here. Yeah, it's quite finicky, but it gets you the exact geometry. All right, so this is pretty good. I feel like this is an appropriate stage of the game, I guess. All right, so we locked the surface, right? Now we're gonna unlock it. This is the key part. You're not gonna zoom or anything. You're not gonna change the magnification. So once you unlock this, you can just drag your finger, and it's very tempting to zoom in to get a larger image, but you have to remember not to do that. Okay, looks good. We did not zoom, we're just panning, right? We scaled it to this vertical stabilizer template, and now we can lock it in place. So now we can't pan or zoom or anything. That's pretty good. And this is how we're gonna get our side profile shape through tracing. Alright, you might be thinking this is like cheating, yo, like what are you doing? But I think, it's just clever. This is like using the tools that you have. If you don't have an iPad, you can definitely still use your laptop screen, but it's just a little bit harder because it's going to be vertical or at an angle. So you have to be careful there. But this is good. If you have an iPad, this is like the easiest way to get geometries done fast. Yeah, so I'm gonna mark several key points here. Right, the first is kind of there, and then you have a little bit of a curve here. Okay, and then we're just gonna mark these panel line areas. Because these panel lines are the real life version of this. It's two pieces of metal, right, sheet metal, coming together, resting on a structural frame on the inside. So you can actually copy that and try and, okay, so this baseline is here, right? So this is kind of the baseline that we're trying to get. Alright, so this is the height of this entire structure. Right, so from here to here, if you draw a relatively straight line, we'll clean this up later. We just need the reference points right now. This thickness is gonna be what we need to loft our plane. This is, it's a little bit more precise than hand drawing, right? And so I think our airplane ends at this nozzle right here. So we'll have to loft this section right here that tapers, and then the nozzle itself starts here. I'll just mark that out. But otherwise, you just lightly dot this because you can't actually mark it too well. Alright, so this is nozzle, right, it comes here, and then this here, and then straight line arc there. So I think for the front here, we're going to have to make like a straight loft here, because the loft structure, it's not outside, right? It's inside this contour, side profile contour. So if we put it inside, we'll be okay. It won't look strange from the side. But this little edge here, we might have to surface model that separately when the time comes. So yeah, that's pretty much it. All right, and then now we don't need our iPad. All right, I'm just gonna put it over there. We just gotta clean up some of these lines now. Taking a sip of Coke. You gotta stay caffeinated. Alright, so this front piece right here, it's gonna be a little bit curved. So we'll do that. Then from here to the back point right here, should be pretty straight, right? And then from here on, it is a little bit curved. Right, the taper is super subtle. I guess if you've studied like aerospace engineering, which I don't know how many of you out there have studied that, but there's this thing called fineness ratio, where I forgot the exact equation, but it's fineness, right, is correlated with high aspect ratio. So something that's like thin and long is very fine, right? So this curve that we just drew here, we could say it's very fine because the amount of curvature compared to the height is not that much, right? So it's a very fine, very subtle contour. So that's that. Now I can draw the main line here. You might want a longer ruler for this bit so that we get a perfectly straight line, right? Just need a point here, right? A point here, 2 points determine a line. If they're not coincident, right? If they're not on top of each other. That's just a fact of geometry. So looks good. Right, draw this. This is like the actual nozzle, so we won't deal with that for now. But yeah, this is the piece here. I think in real life, I think there's like a splitter plate in the intake of the real life F-16. There's like, if you view it down from the front, there's a plate that splits the airstream in half. I think that, routes it, over its landing gear structure, which is going to be like inside the plane. So your landing gear is going to be right about here-ish, right? It's like right near the front of the intake. So you need to actually split the air into two streams to go around that before it can come back and go into the engine. So it's kind of, I think that's why it's there, but you can correct me if I'm wrong if you know more about the F-16 than I do. Just erase some of these weird squiggly lines, but really they don't matter too much, so we don't have to spend too much time fixing that. We do need a kind of a whatchamacallit, it's like a handle, or it's not a handle, it's like an anchor point, right? So we have this cross section. How are we going to attach it to a flat surface at a 90-degree angle, right? So we need a little bit that folds this way or this way, right? So we need a little bit that goes 90 degrees. And to do that, we're just going to kind of eyeball how much we need. This, all right, put that to the side. This aluminum one is nice to use. It's a lot smoother and more controllable, right? Low friction against the backdrop until you apply pressure. Then it's like pretty high friction. So I think for this we only need like I don't know, 1.5 centimeters ish. Even that's a lot, but I don't know. Let's see what the width of this here is. It's about 3. So if we do 1.5, it should be okay. There's like no structural requirement for this, right? It just has to be enough to hold it in place. So you don't want it to be too much, because that's like weight, that's extra weight. But you also don't want it to be too little, in which case you can't mount this lofting structure securely. So it's really kind of a judgment call, right? This is what I call eyeballing. Kind of have to have a good feel for these things, and the way you do that is to practice a lot, right? To make a lot of these aircraft. So we just extended this edge perpendicular to this. Hopefully it's perpendicular. I don't actually have a right angle ruler tool thing, so I can just use my ruler here. There's a specific tool for that, but I just don't have one right now. It's like a right angle triangle. So this looks good. 1.5 inches on both sides, right? Now I just have to complete this this piece right here by just drawing a line, completing it like that. So this loft, right, this entire piece right here on the bottom is the intake. So we can actually just label that so you guys, I don't know, if a new person joins the stream. Intake loft. It's really not the intake loft, it's like the underside, undercarriage, engine, intake, airflow, duct, loft. But that would be too long to write down. So intake loft it is, and then this top part here that we just drew out is the handle. I'm just gonna call it the handle. Handle/anchor. Right. Okay, so that's good. I guess what's next? We need 2 of these, but for template purposes, we only need 1 because we can use the power of symmetry to derive the other shape. So this is good. Let's just label this as forward. Forward right here. Okay. So we only need to make 1 template that we can trace 2 pieces out of this. The reason why we want 2 pieces is if you imagine, like, you know, you have your F-16 right here, right? You have your, you know, triangle wings, your tail, whatever. On the underside of this plane, we're creating this structure right here, right? And to loft that structure, we need, oh shoot, that's not right. All right, that mark specifically. We need 2 panels of this to be mounted like so, right? So that we, I guess it's symmetric, right? We need 2 of these. And the reason why we're not creating this shape with these 2 edges attached to each other is that, you know, there are curved portions here that are not suited to be folded in half, right? If you fold a edge, you can't get this curve. So instead of doing that fold and approximating like this segment here, right, and then like curving this, you know, making that, you know, folded piece is actually quite difficult, the template, right? You gotta move this, right? First of all, you can't be doing it on the edge of the paper here. You gotta move it here, and then you gotta cut it and then mirror it over and then cut it again, right? It takes a little while. This is the most direct way, and since this piece is not like a leading edge aerodynamic piece, I think we can get away with separating the 2 halves here. We just have to trace this template onto cardstock twice and then cut it out twice. So I guess it's like, it's much of a pick your poison type of deal, right? You can create like a double-sided template, but it's just gonna take longer, in my opinion. So this piece, right, and then, so once we have that loft, we can then, you know, I'm just gonna flip this over now, right? We have a loft like that. It's kind of like a T-plate. We can make half cuts along the belly of the plane and then create like, we don't need all of this line right here. We can create like cross sections, right? From the diagram that we got off of Wikipedia, right? We can create cross sections like that with half cuts also. And then, you know, you can give it like a little foot right there, little handle, right? And then you got to double layer this too, right? You don't want it to lean towards one side. So you need 2 pieces like that. And then it fits down here, and that the 2 half cuts fit perfectly, and it's a very, very strong joint. And so that's kind of the plan. And then we got a loft like, you know, the rest of these, etc., etc. So this is kind of like a quick sketch of, I guess, what we are about to do so that you kind of understand where we're going. I know these videos and streams are pretty long, so this is kind of the plan going forward. Um, just gonna draw a tail here, call it a day. Right. All right, so now we can actually cut this and get started. But actually, before we do that, I'm gonna really quickly draw some lines here. And these are the locations where I think we'll need like a loft or cross-section piece, right? So I'm gonna call lofts like this longitudinal piece right here, this very long part. That's gonna be called loft. And for these shorter cross-sectional pieces, I'm gonna call them cross-sections. So this would be a loft, and this would be a cross-section. Cross-section. All right, so that's kind of the terminology that I'm going to use. It might not be accurate in like industry or anything, and that's not really the goal here. We just need to reference the right thing consistently. All right, so I'm gonna draw this line here. So these are parallel, I feel like. So I don't know if we need one on the very front here, because if you put one of these cross sections at the very front, it's just gonna be like, blocked off, and we want to create the illusion that it's an intake, that you can actually go inside of it, right? In flight, this is gonna create a lot of drag, this whole structure, but we want to create a realistic looking F-16, so that's the trade-off, right? You gotta have some more drag, and that's just the trade-off that we are agreeing to. I don't know how many of these we need. This is like, let's see how long this is. This is like 1.65 ish, 1.7 centimeters. So I think this vertical piece right here would end the straight portion. All right, and I really want this to be like evenly spaced out, but in the real life airplane, it's not like that. It's sometimes it's variable, but a lot of the times it's just, well, for them, I guess it is equidistant. You just have a very dense grid of like these vertical structures. It's like, what are you even doing? You might as well just machine the whole thing out of a block of material, but I guess it does save weight in the end. So I'm not actually gonna use this line right here. I'm just trying to figure out, like, get a feel for this, right? If you have a lot of these sections, it's going to increase the amount of time that you spend in making this, right? Each cross section has 2 of these. There are 2 of these cross sections back to back with the little feet and the cuts, and it's a lot of time to manufacture that, right? So we want to reduce the amount of cross sections that we need to make, but if you only have 2, then the middle is very vulnerable, right? Because when you crash on like a tree branch or something, there's going to be like a little object here. When you crash on that, if there's no supporting structure in the middle, then it's like, okay, crap, I just damaged my plane. So there is like a balance point, right? You want to create enough of these cross-sectional supports, but also you don't want to like do a very dense grid, which will be very strong, but it's a lot of weight, right? First of all, weight, and second of all, time. It takes a lot of time to make that. So we got to think this through. I'm just going to erase this real quick because it's in the way. So you guys probably know what this is already, but I'll just write it here. The anchor, we don't really need to erase because that's going to be flat on the thing, on the base. All right, so let's actually do like 3 centimeters proper per cut. So this is going to be, okay, so this straight portion is like 8. We want like a nice round division, proper division of that. So I'm thinking 1 at 4, 1 at 2, 1 at 6. So that'll divide it into 1, 2, 3, 4 pieces here, which should be enough to handle like an impact. I don't know, like if a rock, right, or a branch this size, you know, if you hit it, if it's going to puncture, but I feel like 4 is a nice balance. Also, I just like nice numbers, right? So you saw me earlier trying to like click this line right here that we had up to 3, but we decided against that with the every 2 centimeter idea here. So this is every 2 centimeters. I'm just going to draw the vertical line here. Vertical line here. Same story. All right, that one's already done. So now we have this piece here. All right, this is 8. This is 6. This is 4, 2, 0. Right. All right. This is gonna be the very first cross-sectional piece. So I feel like the way we're gonna do this is we're gonna give it a name, right? And since it's on the bottom and we're done with the top canopy part, we can name it the same thing again. This is gonna be A, B, C, D, E. All right, so A, B, C, D, E are all the same. So maybe I should have just called them A all the way through. A, 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 A. There we go. Much better. I see, like, I don't actually know what I'm doing. I'm just like kind of thinking through this problem as I go. All right, so type A cross sections are going to be identical for all of these locations, and we're not going to put anything forward of that because we want it to look aesthetically like an intake. All right, looks good. And then the back here, all right, so we'll have to, I feel like we'll have to keep on doing the 2 centimeter sections here. So this is not a perfect measurement. It's like a little under 7, but we can still keep the spacing here up until the last point here. So 1 through 7, this part curves a little bit, so we want to make sure we have straight enough of a segment in between to really model the surface, right? This is gonna be a little bit questionable here. Okay, so that's the nozzle. We don't have to worry about that. This is where the nozzle comes and joins. So ideally the last place would be about there, because if that's where the nozzle comes, you don't want the nozzle to be blocked off like the front of the intake. So let's see what the measurement is up until that point. It's 6.5. All right, let's just call it 6.5. Click it to 6.5. All right, so nothing after 6.5. It's just gonna be straight loft. So what's good to be divided? what's 6.5 divisible by? There we go. Use your words, Ben. All right. Well, I don't know why you erased that, but there we go. 6.5 divided by, we need a reasonable number. 5 is a little bit much. 6.5, I don't know, like 2.5? No, 2.5 goes up to 5, and then left with a little segment here. Let's see, where is the curvature the most, I guess, severe? It looks pretty equally spaced out. Like, this could be part of a circle if you extended it out. I'm not sure. So let's see here, 6.5 cm. If we do, I feel like we should do 4 of these sections. No, divide it into 4. Yeah, so 6.5 divided by 4. 1. Point. Whatchamacallit? This is what, 25. That's gonna be 6. 24. 1 0. 2 8 2 0 5. 1.625. All right. That's not. I don't think our ruler is precise to that amount, but we're gonna try. So 1.6. 25. Then 1.625. Oh shoot, that was not 1.625. God damn it. I am bad at measuring. Today I learned. There we go. Much better. Erase the first one. Hey, this would be much easier on a computer, right? CAD work. Because if you're trying to make like a exact model. But here I am with pencil and paper, so anybody can do this. 625 is a little bit over, but right there. 0.625, right about there. All right, right there, there, and there. Now we are going to draw the lines here. These are all going to be different, so it'll be B, C, D, E. Yes, E comes after D. I had to think about that for a second. See, it's Friday afternoon, right? My brain isn't working anymore. It's like fried. Anyways. Precision alignment. The line there. Draw the line there. Okay, this is gonna be section B, C, D, and oh shoot, we forgot the last section. All right, there we go. I have to align it with that point right there, not the nozzle point. This is gonna be E. This comes down. Fix that. So we have to create a template for A. Shoot, let me move this over a little bit. There we go. All right. So we gotta create a template for A. And that's gonna stay the same for like most of this. And then we gotta create one for B, which is gonna be about the same, but slightly thinner. And then C is gonna be thinner than that. D is gonna be thinner than that. E is gonna be okay. So I guess now, oh god, all right, let's hope that this works. We gotta do a dry fit to see if this actually makes sense on the actual airplane, because we might have scaled the tail, right, and everything properly, but if it doesn't fit to our plane, then we're pretty much screwed. You might be wondering, like, why didn't we use the plane to scale everything instead of using the template when we were doing stuff on the iPad, right? So my answer to that would be, I don't know. I think the tail is probably just easier to get and to manipulate on the screen than a 3D object like our plane right now. So that's why. It's probably better to use the plane, but it's a 3D object and I don't want to like risk moving the scale or changing it, you know, because some materials are conductive and they can replicate the I guess the input of a finger. So we're gonna cut this out and see if our scaling work and profiling here is actually going to it's actually gonna work. This is going to be very interesting. All right. I'll definitely use a straight edge cutter, but I find this to be unnecessary, especially since the contour is curved near the back end, so the amount of time that you save is not a lot. All right, looks good. Now comes the fun part. Hold this anchor down, and we're gonna slide our ruler underneath. I'm gonna align this together. Right on that line. Precise. And then we're just gonna pinch it. Once it's pinched, it's all set to go. Just fold it over, increase the intensity of the fold. Roll it to the side, take a sip of Coke real quick. Okay, moment of truth. Does this actually look reasonable? And the answer is probably not. This looks very thick. All right, this is why you need to do a check. This is quite thick. I'm not sure if this looks right. But then again, I said that about the tail, and now it looks like it's in scale. So, I don't know, you tell me, does this look right? I don't know if it looks right. Can you imagine the rest of the plane down here? Or not? That's kind of my question to you, dear viewer of the stream. If we do this, let's see. I'm gonna check the chat real quick. All right, so I do have a question. So will air go in the intake and pass through the body with the flat support structure that creates the shape? Or will there be holes for air to travel through at this scale? Would it matter? I think your last question there, Ben, is the most important. At this scale, right, air doesn't behave the same way that it does on the actual real life F-16. So an intake like this with this much space would not experience the same kind of air going into, well, I mean, the air itself is the same, which is why it doesn't scale, right? Air, viscosity is constant. It does not depend on your structure, right? So how do I say this? So if you think about like a like a passenger jet, right? You think about a Boeing 737. It's flying through the air. Its wings, its engines experience air at a different kind of feeling, right? Like if you think about it, it's like swimming through water. Like imagine yourself swimming through water, and then for a little bug, like a little ant or something, that water is going to be super difficult to travel through, right? Because the water is viscous, right? There's sheer friction between molecules and things like that. And for water, there's even um, surface tension and things like that. But that aside, that amount of force acting on you, you're gonna experience it a lot easier, right? It's a lot easier to swim through water than say for an insect, which it's gonna be very very difficult. But think about like a Boeing 737 flying through the air, right? The air, it's traveling over the wings, right? And you're flying great. Um, it's laminar, right? I'm trying to think of words to say here. It's it experiences it differently, right? If you think about a butterfly flying through the air, that air is gonna be, it's gonna feel like honey, right? If you think about it, it's gonna feel like honey, um, the same way you and I would experience, um, I guess, things. So there's this thing in aerodynamics. There really is this thing called Reynolds number. It's a very interesting concept to try and understand, right? It's RE equals rho v c over mu. This is air density, right? This is your speed. This is your geometric chord, and then this is your viscosity. So basically, when you change your chord, which is when you change the size of your thing that you're considering, whether it be a butterfly or a 737, when you change this, these two still stay the same, right? But if you increase this, because this is such a small number down here, the viscosity, right, it's gonna be a huge difference. So usually for like passenger jets and things like that, you get Reynolds number of like, you know, 3 million or something like that. You know, um, it's quite large. But for things like butterflies, it might be like a reasonable number around like 6-ish, right? So this is like a weird equation. You might not understand it, but it's basically your inertial forces relative to viscous forces. Right? So how you carry through yourself, like how you carry through the air versus the amount that the air is pulling back on through viscous forces. Right? So if you think about that, a passenger jet has a lot of inertia. Right? It's going to cut through the air a lot easier than a butterfly. Right? And it's a whole interesting field on its own. This RE, this Reynolds number here, is very interesting because it can tell you a lot about when an aircraft will stall, right? Because if you have like a very thin wing like this, right? Imagine this as a wing, and it's flying through the wind tunnel. Um, you're blowing air over it. The air will be pretty laminar up until a higher angle, right? Because it's smaller. This object is smaller. But if you have like a full size, like 12-inch RC plane wing, right, something like this, even a slight angle will cause it, to stall. The air will separate, right? And then so that has to do with Reynolds number and how the viscous forces behave relative to the object. So hopefully you enjoyed that little, I guess, lecture. But really quick, it's just inertia versus viscous forces. Inertial forces versus viscous forces. And so at this small scale of an RC, it's not even an RC plane, it's literally just a glider. the intake structure will not allow a ton of air to pass through, even if it were hollow, because air is very viscous. And imagine carrying this structure through the air, right? If it's very viscous, when you blow into it, it's not gonna want to move. The air is gonna be sticky, and it's like, okay, you know. I don't know how else to describe it. It's just harder to blow through like a tube. Imagine a tube, right? And you know, you're trying to blow through it. You can get a certain velocity, but that air in like a larger cavity will flow through it better, right? The same principle here with the inertia and the mass, or inertia and viscous forces. So it's, yeah. So at this scale, essentially, at this scale, it doesn't matter. The air will probably go around it whether it's hollow or not. Um, and that's just how it is. Yeah. So long-winded answer, but you kind of know some of the physics behind it now. So hopefully you're a little bit more educated on this topic. So what I don't understand right now is how we scaled this thing incorrectly. This is bullshit. Because we measured it on the iPad, it was exactly correct, and this bit here goes a full, I don't know, like an inch past where it's supposed to end, because the nozzle is supposed to come here and then go back, right? But then this piece right here is like a little bit past that, and so because of this little bit, it's a little thicker than we expected too. So I honestly don't know how to handle this, because getting this right is the key to getting like a proper, good-looking intake structure. So we do need to spend the time here. So even if today all we do is determine this cross section, then that's what we're gonna do. Because we already put so much time into this, we should probably make it as decent as we can. So to me, God, this is gonna be a little bit difficult. Let me just grab my iPad real quick again. All right, so this is bullshit. We scaled it to the drawing, and it still doesn't work. All right, we're gonna have to diagnose this problem real quick. Let's lock this in place. All right, so here we have our F16 and the drawing F16. Looks great. Matches perfectly. Okay. We have something like this. The canopy isn't exactly to spec. Oh my goodness. I miscalculated a detail. So it turns out this is not actually the base. Our base is, let's see. This is why I'm saying like it's really hard to like align things in 3D because it's already 3D. So, oh my god, this is really hard. I'm just like trying to view it from like high up above. And let's move this up a little bit. That does not make sense. This does not make sense to me at all. Alright, so let's just use our common sense here. This intake is about the size of this, which is ahead of this little reinforcement, canopy reinforcement. This amount of thickness. Actually, this is a little less than that. This is like, I don't know, 3/4. Yeah, it's about 3/4 of this height. Okay, so if we do that here, get a height for this thing. This is 1.5. So, oh my god. All right, let's calculate that real quick. All right, so we got 1.5 centimeters times 3 over 4. All right, so that's about 1 point. 1 point whatever. 1.1. Is that about where we're at? Nope, we are at 1.6. Remember? We calculated that. God damn it. All right. So I think I like this shape. It's, it's traced off the right scale. We just put the wrong amount of offset, I guess height for the A series cross sections. So we just need to like lower this line down a little bit.
Okay.
Oh my goodness. Siri's like, what the fuck? All right. Yeah, so that's my bad. I did not notice the baseline is actually lower than we expected. Because in the drawing, I felt like this tail, right? This tail is right at the baseline here. So I thought that was reasonable, but apparently not. Based off of a ratio, we determined that about 1.2-ish. We can do 1.2, right? It's still like 1.12, so it's like in between. So we'll try and get that measurement and make this correction here. So this would drop it down to about here, which would look a lot more reasonable. Right, something like that. Since the A cross sections are all the same thickness, the last point where I can make this measurement is right here. Of course, you can go the other way and measure the difference, but I just remember 1.15, 1.12, but you can't really measure that accurately, so I'll just do 1.15. Sorry about that. Let me just zoom in a little bit so you guys can see. Wow, that is very overexposed. Sorry about that. All right, so this is the point right here. This is the point right here. 2 points, determine a line. Oh my god. All right, here we go. Pinpoint there, and then just draw this, right? All right, now I just gotta modify the handle area. Now handle doesn't need to go ahead of our piece, so you could slice off. Oh shit, I drew my ruler. All right, I just erase that. And to reduce the amount of confusion, I'm going to erase these lines here. Okay. I don't think our handle needs to be this massive, so I'm gonna reduce the size of that. I think 1 centimeter is good. It's proportional to the amount of thickness that it has. That'll be good. And I'll do the same here. Sorry if that was off camera. I am in the zone right now. This is what psychologists call flow, state of flow. When you're doing something you're passionate about, you lose track of sense of time. That's flow. I think the hardest part for me about this hobby is getting started. Right, it's a lot of work, but once you get started, it's like, okay, I gotta get through this. And then sometimes I spend like afternoons just tinkering away. All right, so we gotta move that handle, anchor, designation.
below. All right, erase that. I don't really need these numbers, just for reference. So these are 2 cm. Shoot, yeah, these are different, but since they're marked down already, we don't really care about the numbers. They were like what, like 1 point something. I forgot the number. So very curious to know. 1.15 ish. Oh, what do you know? That's like the thickness of this. I don't know. All right, whatever. We got to trim this area off, get rid of it. It's excess. We don't need that much handle, that much of a anchor. So, all right, let's start trimming this. Now this, I feel like a straight edge cutter would be useful because the whole thing is straight. We don't want a curved piece. Oh my god, all right. Let's get our straight edge cutter here. These are all the scrap pieces that I've accumulated for this project. I haven't thrown them away because sometimes you want to reference past things, which makes my workspace a little bit messy. That's okay. Okay, oh, where did it go? It's right there. So just move it to one side, fold it down. Oh my goodness, there's not enough clearance to hold it. Oh god, this sucks. I want to get one of those like slicer straight edge cutters, not like the slidey straight edge cutter. This is painful, yo. Because we don't have enough clearance to put it through. Crap. Alright, you know what? Doesn't hurt. I'll just do it by hand. God damn it. If we had a little bit more paper here, we would definitely straight edge cut it, but since it's too late for that, I just have to cut it by hand. It's not gonna be perfect, but it's the best we can do. So there's that. Okay, now we can do the same thing that we did before. Just line this edge up and then pinch the heck out of it. All right, looks good, and just fold this. Work off of that. Shoot. Okay. All right, I'm trying to see how this fits. I think this looks great. This is like the proper cross section. I mean, the color will visually impact the balance, right? It's a lot lighter here. It's white, you know, printer paper. So it'll feel a little bit off, but you have to try and ignore that and see the contour itself. And to me, the contour itself looks decent. The only thing that I might want to adjust here is the front bit here. This looks okay, but I feel like to get it to fit, we'll have to modify the front a little bit. We might have to cut a bit of the structure here to relieve that, angled. It's like a ramp, right? So it's gonna impart a little bit of displacement on this piece and cause stress there. So we have to, okay, well, let's do this right now. Do it real quick. This is where the piece ends. Shoot, I need lead. Alright. This is where the piece ends. So if we drop that down, we'll have to cut this piece, and then let's mark that real quick. Drop that down. This edge we're gonna cut, and then this forward piece here needs to be notched a little bit. That notch will help accommodate that slight ramp on this nose piece right here. So hopefully I don't confuse myself and cut this entire part out, but if I do, then oh well, that's, it is what it is. That also reminds me though, this intake is not like directly attached. There's like a splitter plate, but I don't feel like modeling that, right? Because like on the real life airplane for the F-16, let's just move this up a little bit. The F-16, you have like a, your side profile, like your nose here, but then your engine is actually like down here, and there's this splitter plate, which I go over the function of in a previous video about the X02, the scale model. But I don't know if we want to model that. It's quite complicated to create that structure. And at this scale, it doesn't make a tangible physical effect. So I don't know if I want to make the splitter plate. But this just kind of reminded me of that, because if we fit this underneath, this cross section underneath, then, or this loft, I shouldn't be consistent. Then if we notch it, we might actually be able to, if we notch it more severely, I guess, it might approximate kind of the splitter plate. Do you see that? That little triangular area, if you cut that out, the intake will appear to be hanging off, and there's a gap in between the inlet and the aircraft. So I'm not sure if I want to do that, actually, like use that to our advantage. But I feel like even if we did do that, the fact that this has thickness right here is going to cancel out any effects that we have. So I don't think we should worry about that. It is like a very characteristic thing for the F-16, but I don't think it's worth it at this point. All of that complexity just for a splitter plate that doesn't even do anything physically, and it's a small minor detail, so I think we can forgo that. We're not building like a scale model, we're building like a flight capable F-16, right? That just happens to look really great. So we have to remember our initial goal here. So with that said, I am going to start. Okay. I guess we should draw the halfway points on these just to be sure. We really need this to be well done and precise, because this is like the core centerline loft. So I don't mind spending extra time doing this. It's a key part of the F-16. So A is 1.1 1. I think we're gonna go to like half, right? So we'll just do a half cut up to like 1, like 0.55 right here. So we'll mark this in. Again, these half cuts, they can kind of vary a little bit off of the nominal, which we are drawing now, but we still want a good reference for them. Right, so yeah, this is a little bit messy, but I'm gonna use this to guide myself in the future. So this is right there. Okay, looks good. Again, this is section A, right? Good thing this plane doesn't have too much of a curve, because if it did, something like the F-22 or SU, especially the flankers, goddamn, those flankers have so many curves. Like, you would be modeling this for ages. Be doing this for ages. All right. This is the last A. Oh shoot! All right, slipped a little bit there. Last A section there, and then this is about the same. B is about the same. It's okay. It's actually quite similar, but I'll just mark it out anyway. This is what, 1, so we could do exactly 0.5. Half cut. This is 0.9, so we can do 4.5 here. And then this is like 0.7, so you can do 0.35, about 4-ish right there. Half cut. Okay, we have everything marked out. We have this template cut out. Okay, time for the real thing, I guess. Here we go. Just gonna grab a piece of cardstock that I have here. And we're gonna start, okay, so we can't put it like this. Looks like we can only orient it like this. We are going to start manufacturing this center line loft. I'm aligning it to the edge here so that I don't have too much left to draw and trace. Right, reduce the amount of effort needed. Okay, this looks good. Do need to mark where this ends. Okay, this is gonna be a little bit rough. But here we go. Oh, I think I gave myself a paper cut there. Fuck. That sucks. Alright, zoom out a little bit. Trace this. Oh, okay. I'm just gonna mark each of these locations so that we have an easier time in transferring everything over. Right there. Then also right about here. Okay, looks good. Now I can trace that shape. Not trace, I mean, you know, just draw out the edges and whatnot. So this will define the handle from the actual loft. Okay, looks good. And just zoom a little bit closer there. Bring it a little bit closer there. There we go. Take a sip. All right. 90 degrees. This is like, what? Erase half of that. Oh, it doesn't matter, right? It's gonna vary anyway, so we can eyeball halfway lines. Again, this is not a precision engineered product. If it were, everything would be digital. It wouldn't be hand making things. And then, here we go. Okay, looks good. Looks good. Okay, there we go. There we go. Thought that was the last one. That is not the last one. There we go. Last one. Finally, we are done. All right, so this is the cut. This is the fold. These are the half cuts that we need to make. But we won't really make these cuts until we make our second piece, and then attach them together. Because once we do that, since this side is marked, we can just cut this double layered piece that we make once, so we don't have to mark this again on the other side. So that's just a strategy to reduce time again, you know. Also to get better quality, because if you cut it separately, it might mismatch. It might be mismatched, right? So if you cut it together, it'll be perfectly aligned. So. Okay. For this, you need a steady, patient hand. You cannot rush these things. Tracing the template. Okay. looks decent. A little bit of wiggliness here. That's nothing a ruler can't fix. Alright, looks good. Oh shoot, should have marked out the locations, the main locations here for the fold. I'll have to align this again to quickly do that. Okay, it's gonna be right about here. Then you might not be able to see this, but I will be able to. It'll be right about. Okay. And we do need to mark a straight line there as well. Let's just reinforce this line a little. Okay, that's reinforced. Need a little bit more lead. Okay, 1 point there, 2nd point down here. Ooh, that was a little rough, but that's good. All right, we are good to go. We have our 2 pieces marked down. We are going to cut this outline first, right from here to here to here, so that we have an easier time cutting the rest. Okay. And to avoid cutting multiple times, I am going to just cut this contour directly. This light source is a little difficult to work with because it generates shadows on your workpiece. So you want to try and angle yourself so that you can see where you're cutting and not be blinded by a shadow. I guess you can't really be blinded by a shadow, it's just obscured. You know, your workpiece, you want to see where you're cutting. You don't want the line to be obscured by a shadow. There we go. Much better. It's just gonna take a little longer. There we go. Looks good. All right. Slip this underneath. Great. Okay, we can put this to the side, clear up some workspace. Okay, move that. Move that. Okay, here comes the interesting bit where I cut the other guy's contour right here. Probably could cut this with a straight edge tool, but I just want absolute control over this bit. this is forward. We do need to know that. If we don't, man, we might accidentally invert the whole thing. This looks good. This is the first cross section done. And this is the second one that we just need to clean up by cutting this strip right here. Looks good. Alright, so I think we are ready to fold. Put this aside. Slip this underneath. Oh god, this is difficult. Yeah. It's a very stiff workpiece, so you gotta lift it up and then put your ruler underneath. And you pinch. Right, looks good. Not sure. Should we intensify the fold? Because it is a structural piece. If it's too floppy, then it's no good. So we don't necessarily want to do that. But that also means for the other side, we need to draw this line again on the opposite side. So I'm going to mark this location here, just like that. And then I'm going to do the same here, and then we're going to draw a line on the other side because we need to fold it the other way. It's a symmetric piece. That's why we're doing this. And then this would be forward right here. It's a very small detail, but you don't want to fold this structural piece too many times. I feel like it'll solve the problem of, I guess, marking, or I guess lack of marking, but let's see, is this good? Might be a little bit off. Let's try this again. There we go. A little deeper here. Alright, let me erase this so that we know not to fold according to this side. We need to fold on the other side because it's a mirror symmetric piece. Okay, this goes on here, on the underside like that, and then this goes on the other side, so it has to fold like this, right? That makes sense. Makes sense to me. All right, here we go. There we go. Shit, I forgot to slide my ruler underneath again. Damn it. Use a X-Acto knife to pry up one edge there. Looks good. Right. So So that's our piece. That's our finished center loft. Well, not quite finished, but you get the idea. This needs to be intensified a little bit more, this fold. But the reason why we didn't want to fold this too many times is because if you notice, right, this piece right now, shoot, let me just do this real quick. This piece right now has a little bit of tendency for this anchor to be, you know, to point out a little bit, right? So if you notice this, it likes, so this is the position that we're gonna tape it into. But if you hold this in place, the center loft wants to go to the other side. And if we balance that with the tendency from the other side, like this, then we're gonna have a pretty straight loft, right? Well, it depends on the amount, right? But we want it to be compressing together so that it doesn't separate. Because when it separates, that's when things can go really bad, structurally speaking. So this is how it's going to be assembled. I think we are pretty much done here. We just need to tape this together. And to do that, we are going to start with the very front here. Just grab a tiny piece of tape. We don't need all that much. I'm grabbing the thickness of this leading edge of the loft. This part will actually touch air. Like in flight, it'll take the brunt of air coming in. Okay, so we tape that pretty tightly. Right, pinch that, right? Wow, that is exact. How do we get that exact of a line? We used rulers. That's the trick. Okay, just take that, fold that over. Slight trim there. Alright, so this is the way it's gonna be. Right, so you notice we only taped that on the ends here. This center portion is open, but when we try and press it down, it'll seal up, right? I don't know if you guys can notice that, but it's a very small detail, right? There's a gap right there. But if we, you know, tape this, which has a little Y shape here, if we flatten this part out by pushing it down, it seals up that little gap. So that's a very small detail, but that's why we switched it over to the other side and then marked it and then folded it. Because if we marked it on one side, this piece right here, which would be forward like this, you would have to reverse this fold, and so this side would be a lot weaker than the other side, and you would actually get a little bit of asymmetry. So that's kind of the reasoning behind that. It's a very niche little detail, but I think it's worth it. So this is looking good. I will say, I feel like for the first, what was it? Section A is the same thickness. So it's pretty much straight from the first one to the 1, 2, 3, 4, 5 to the fifth one. So we might be able to tape that. No, just kidding. 5 lines, 4 sections. So we can tape this section right here just to help secure it a little bit better. And you might be wondering, like, why do that if you could have just made a double-sided template in the first place? Well, double-sided templates take a long time. I mean, this also took a long time, but I feel like this way is more precise for the loft line. So 1, 2, 3, 4. There we go. Up until this point. Just keep on pulling. There we go. And for this piece of tape, we don't need the full length, or full width, rather. Cut this. All right, this is looking good. Forward is there. What I gotta do is, oh shoot, you guys can't see. Sorry about that. Align this. Like that. And then just really carefully, while it's being pressed down, you can pinch it. Make sure that seam is gone. Just like that, you're done with that little bit. There's a little tiny bit of excess here, but you can trim that off. Very, very slight amount, so it's not too impactful, I feel like. Okay, there's just a little bit of reinforcement down there. Okay, so let's put this piece to the side. Let's see how it fits, yeah. Alright, this is the forward end. Probably should have drawn forward down here. Okay, there we go. That's a little bit better. Now I can better see it. Now this is gonna fit down here up until this line right here. Oh, sorry about that. That looks really good. It's just a loft. It ain't even the full thing yet, but this already gives it so much definition. This overall aircraft. Precision made. Custom fit to this plane. And then just gotta create the cross sections, and then install those, and then surface model over that. So we still have a ways to go, but we are getting there slowly but surely. One thing I did forget to do was that little notch at the front. So I'm gonna do that now. We need to cut how much of this? Alright, zoom this back down a little bit. Just mark this location here. We need to cut that much in and a little bit down to accommodate that. Alright, so this is like a very, very slight notch. This will allow it to relieve stress and fit a little bit better. So I need to cut both of these. Just gotta be careful about it. This is double layered, so we gotta be extra careful. There we go. Make sure the layers don't shift when you cut. There we go. Okay, so we cut out this little tiny notch here. Might be able to see that. Alright, and then now this should fit better with the front. Ooh, that's beautiful. Alright, so did you see that? Probably didn't. That's why I'm going to show you right now. But look at this. You line it with the front edge here. Right? Kind of looks like that. There's a weird gap there. Let me just put like a white background so you guys can see better. You see that? See that little gap? You line it up, and then you press in, and it's gone. And the intake looks great. So, small detail. Something like that. Yeah, it looks good. All right, what we're gonna do now, I don't know if we should mount this. Should we mount it? If we mount it, I can't really put this thing anywhere. But I feel like we do need to mount it before we can create the cross sections and start installing them. So, I don't know. We're at about 120 right now. So, right about close to 2 hours. Got 10 minutes left. I feel like that's the only thing that we have left to do, really. Because once we install this, then it's just a matter of slowly working our way through through the cross sections. Excuse me, sorry about that. Okay, so let's do that. All right, just need a measurement here for the width to find the center, because this is a major structural piece. We want it to be aligned properly. So this is about 3.3. What's 3.3 divided by 2? 1.5 plus 1.5. So that's 1.65. Okay, that looks good. And yeah, just gotta measure the back here. It's approximately 4. It's like 4.1, so like 2.05-ish. There we go. Forward to forward, aft to aft. Okay. So I still have that massively long piece of tape that we had from before. I can cut little slivers off of it. And attach it to these little tabs here. I'm gonna keep this there. Cut another tab. We'll use approximately right here. We're slowly but surely getting there. I'm just gonna tentatively place one of these. Place it, or press it down, I mean. We're going to take the opposite corner here. Place a piece right there. Then we are going to align it, press down. Fold this in. All right, looks good. And then pinch together. Fold down like that. Something like that. And then the last piece here, and just go on without a hitch. Just gonna change angles real quick, get at it. Once it's on, pinch it a little bit, and then fold it over. Like that. And we are done. So it's a little bit springy, but that'll keep it relatively unwarped. If you press it down, it looks like it'll warp a little bit because the bottom isn't perfectly three-dimensional, or perfectly flat rather. So this little, springiness, this little gap is actually good. It's good for fit purposes. We might have to taper this aft section here, custom tailor the OML, but we will save that for next time. We have like 5 minutes left. Let's just tape these sides here and then call it a day. This is going to be a pretty long strand of tape. Alright, so the way I'm going to do this, I'll place it at an angle here. Grab the tip first, and then trim that. We'll also have to trim that, but let's just get the other piece of tape on. That's the critical bit. So another strand of tape like this. Okay, looks good. Quite long, I do realize. Let me just turn it the other way, like that. Grab the outboard. Alright. Tape. Tape down. Okay, it looks good. I just gotta clean up the edges a little bit with our X-Acto. And we'll be all set. Okay, let's do it the other way then. To the scrap heap you go. There we go. Okay, looks decent. I'll have to smooth some of this taping out later. Okay, looks good. Just gotta clean up the back end here. This is just some delicate work here. Cut from the other side. There we go. All right, and we are done. We are done with today. All right. Yeah, it's been a while since we started progress on the intake, but it looks good so far. We just need to do the actual cross sections, right? We marked out the locations for those, so next time we'll get started on that. But it's looking good so far, right? The back end here might be a little thick, but we'll adjust the outer mold line as we see fit next time. So that's been it, guys. Thanks for watching. Continue with your projects, right? Definitely stay safe and healthy in these times. But yeah, next week we will continue work on this. And until next time, I guess I'll see you guys later. Thanks for watching.